Hey guys, this is Sanjay from FTC Team 7477, Super 7. Today, I'm going to be talking about the linked list class in Java. So, previously, we've done some videos about array lists, but between linked list and array list, there are a few key differences. For one, unlike array list, which uses an array under the hood, linked list is implemented as a doubly linked list, which makes it really efficient for insertions and deletions and other stuff like that. So first, let's talk about how we actually import linked list. This time there's only one import statement, which would be import java.util.linkedList. So the linked list class is a part of java.util, so we have to import it before using it. Next, let's make our class and our main method. My class would be public class main, since my file name must match my class name. Next, let's do our main method, which would be public static void main string and args. So now we can start coding. So to show how creating and adding elements works, let's first create a new linked list. The way we would do this is linked list, and let's do our string as our data type. So linked list string, let's just call it list, equals new linked list. It's similar to how you would create a new array list. So we can do stuff like list.add. So you want to add an apple to our list, and there's also some other methods like list.add first. So just add something to the first position in a list. So let's add banana to the first. And just like add first, inversely, there's add last, which, as you would expect, adds something to the end of the list, the last part, the last index of the list. So you could do list.add last. Let's add super 7. And we can print out our list just to show how it works. So if we print this out, we got our list, which is banana, since we did add first, apple, and super 7, since we added it last. Next, let's talk about removing elements. So it's pretty much the same as adding elements. So let's say I'm going to keep the same stuff in our list. So let's say we want to remove something from our list, right? So let's say we want to remove the string banana. You would just simply do list dot remove, and let's just make it banana because we want to remove all the bananas. Additionally, you also have the same it's kind of the same methods as add first and add last. Instead of being add first, it's remove first, and instead of being add last, it's remove last. So let me show you how this works. You just do list dot remove first. We don't need to provide any arguments because the element at the first position index in the list is always constant. We don't have to provide Java with anything to remove it. It doesn't require any external information. We can also do remove last. So we would do list dot remove last. So elements can be removed using remove first, and remove last. Here we remove banana from our list, the first element from our list, and the last element from our list. So if we try printing our list out using IntelliJ built-in shortcut, so let's print out list, we would simply get nothing because we just removed all the elements from our list. So let's talk about accessing elements. So I'm just going to remove the remove part. So to access elements, let's just try printing this out just to see. So using IntelliJ built-in shortcut, sout. So to access the first element in the list, you would just do list.get first. And to access the last element in the list, we can also print that out using sout. You just do list.get last. Pretty simple. So if I print this out, oh, I did not mean to do that. So we have this. It prints out the first element in our list, which is banana, because we did list.add first banana, and we print out the last element in our list, which is which is super 7, since we did list.add last on super 7. And then we can print out our finished list, which is banana apple super 7. So we can access the first and last elements using get first and get last. Unlike an array, accessing elements in the middle requires traversing the list. By traversing the list, I mean iterating over the list more specifically. So the way you would do this is using a simple for loop. So let's say I have this, right? So for string item, just a placeholder variable. So let's say I was doing a more conventional for loop, like int I equals 0, I is less than like 5, int I. This is pretty much a standard form of traversing stuff. So there's two main forms you could do this. You would just do you would use a get index command, which I'm not going to cover in this video, but in a more advanced video about linked lists. So the standard convention for traversing items in a list that are strings would be for string item, item is just a placeholder, colon list, which means in list. So for string item in a list, let's just print out item. So let's see what happens when you run this. It prints out each member of our list individually, going from index 0 to index 1 to index 2. So we can iterate over the linked list using a for each loop, just like with an array list. So in conclusion, linked list is a doubly linked list, making insertions and deletions efficient. We can add, remove, and retrieve elements easily. It's best used when frequent insertions and deletions are needed, but ArrayList is much faster for random access. Thank you guys for watching this Super Programming tutorial, and see you next time.